All right, so this problem that you guys just tried out here, its only difference is that instead of rotating around one of these axes, it's now going around this line right here, x equals 3. So if you're having trouble visualizing the shape, this is kind of like one inside slice of it, rotating around this way. So it kind of look like that on this side. Kind of like that. So it's definitely going to be a washer, just because it's got this gap in the middle here. So let's just do like we always do. Take one slice of it, just one slice, and that's what we use to determine the integral we have to do. So I'm going to use this slice right here, and so that's a horizontal. So I'm using dy. So like dy is my height of that one slice. In a washer, I need inner and outer radius, basically. So let's do the outer one first. Well, that'd be from this blue line all the way to this line. And at every single slice, it's that same distance. So that's a distance of 3, right? Because this is x equals 3. So that's, let's see, pi r squared, pi 3 squared. So that's the outer radius minus the inner radius. This one's a little bit trickier to see, so let's just break it down. First of all, that is the line. The red line is y equals. Oh, let me go back to the question. I don't know what it was. Is y equals 4 minus x squared. Okay. So let's just do it like every time. Look at like one slice. Well, right here, that would be. Let me get rid of these little lines here. So I take this slice right here. The inner radius is this distance right here. Right here, it's this distance right here. So how do I get that each time? Well, what I know is this red line, the x value of this red line at any moment. I know that, but it isn't just x though. It's what's left over from x. If this is x, then this distance is what I want right here. So that would be each time it's starting at like a distance of 3 and then taking away this little chunk here, which is the x value of this line. So obviously first I need to go ahead and change this into an x equals, and I knew we were going to have to do that because we're using dy, and this is in x, so I need to flip that over. So this will become y minus 4 equals negative x. That becomes x squared equals 4 minus y, and then x equals the square root of 4 minus y. All right, so that right there is your x each time. And this distance that you want right here each time is the full 3 minus the x value. So that's going to be the radius. So pi r, but each time r is 3 minus x squared. So pi r squared dy. Let's see, I'm integrating from, these are y's, these are horizontal slices. So look at your y values, you're integrating from 0 up to 4. Cool. Obviously there's a problem, that's an x, so I can't have that, but I already have x over here, so I just need to rewrite this, 0 to 4, pi, that's just 9, minus pi, 3 minus the square root of 4 minus y squared dy. And we type in, we get something like 75.39. 75, yeah, let's do 339, why not? 390. All right, so here's another one for you to try with. We're gonna use the same shape, but this time we're going to rotate it around the line y equals -5. So it's that same shape, but think about how now it's the line y equals -5. So let's see, that's too much right there. 1, 2, 3, 4, 5. So we're rotating around this line like that. Okay, so hopefully you got a chance to draw that out and see what it looks like. I'm not really going to attempt to draw it out. I think that might just hurt at this point. So, but again, I really am worried about just one slice, right? As always, just worried about one slice. Taking that one slice and rotating it around this would give me a washer. So this is another washer method. Let's see. These are vertical slices now. So. And that's just based on what we're rotating around, okay? Because we're rotating around a y line, like a y equals line, then that's why I'm using vertical slices. Let's see. So looking at my graph, this goes from 0 to 2. The same graph as I had above. So let's see, 0 to 2. Okay. So dx is my width essentially, or height. Okay. All right, so let's look at the outer radius. The outer radius, that would be, if I were drawing one slice, that would be from right here all the way down to this. That's the outer radius. Well, this distance is 5. And then this distance is some y value, whatever the y value of this curve is. So it'd be pi, and then r is 5 plus that distance right there, which is y. So 5 plus y. Plus y. That's the outer radius. Pi r squared minus the inner radius. Which it looks like it would just be 5 the whole time, right? It's just the inner radius is always going to be this distance right here, and that's just 5. So minus pi 5 squared. So let's put all this together. 0, 2 pi. Now I don't want a y in there, but I know that this is the same line as before, which is y equal 4 minus x squared. So I'm going to make that substitution. 5 plus 4 minus x squared minus, that's just 25 pi. All of that times dx. And that gives us 221.168.